Hi everyone, my name is Bella. You can also call me Pi. I've been getting a lot of questions lately about Epsilon-Delta definition of a limit. I love this kind of questions because it sounds intimidating at first, but it's actually super easy. And you don't need to always refresh yourself with all kinds of sophisticated theories every time when you see that you need to prove something, okay? So today, I'm just going to show you the shortcuts without telling you or explaining the whole universe to you. So first, I'm going to tell you what is the general beginning of this kind of question. Suppose epsilon is a positive number. We must find delta greater than 0 such that if the absolute value of x minus a is less than delta and greater than 0, then the absolute value of f of x minus L is less than epsilon. So in this question 17, prove that the limit of negative 2x plus 1 as x approaches negative 2 is 5. You see what we need to do? We need to find the a and the L, right? So in this problem, we can transform the whole definition into the absolute value of x minus negative 2 is less than delta, which implies that the absolute value of f of x minus 5 is less than epsilon. So f of x equals negative 2 plus 1 and a equals negative 2. And the L equals 5. Let's proceed. The absolute value of 2x plus 1 minus 5 is less than epsilon. This is equivalent to the absolute value of negative 2x minus 4 being less than epsilon, which is the same as the absolute value of negative 2 times the quantity x plus 2 being less than epsilon, which becomes the absolute value of 2 times the absolute value of x plus 2 being less than epsilon, which is the same as 2 times the absolute value of x plus 2 being less than epsilon. So the absolute value of x plus 2 is less than epsilon divided by 2. So we take delta to be epsilon divided by 2. And now I'm gonna use 3 more examples from the textbook to show you why this method works. What I will be writing below is not complete or standard steps that you should be writing during the exam. It's the simplified steps to save your time and my time. Okay, so the key here is to factor out a constant so that the absolute value of f of x minus L become a multiple of the absolute value of x minus a, as we did before in our last example. Okay, so problem 18. The limit as x approaches 1 of the expression of 2x minus 5 equals negative 3. So now the first step is to find the a and the L. So what is the a here? A is relevant to, yes, the x value. So here the a is 1. And what is the L? The L should be something that is related to the value of the function. And in this case, the L is minus 3. Okay, so what we are going to do is to plug in the numbers and to establish a relation between the two functions. So the absolute value of f of x minus L becomes the absolute value of 2x minus 5 minus negative 3, which implies to the absolute value of 2x minus 2, and this equals 2 times the absolute value of x minus 1. And the absolute value of x minus a becomes the absolute value of x minus 1. and there's a multiple of 2 between the functions. So we want the absolute value of f of x minus L to be less than epsilon, which is equivalent to 2 times the absolute value of x minus 1 being less than epsilon. Therefore, the absolute value of x minus 1 is less than epsilon divided by 2. Thus, choosing delta equals epsilon divided by 2. Now, let's go to problem 19. The limit as x approaches 9 of the expression 1 minus 1/3 x equals negative 2. The limit value of f of x minus L becomes the absolute value of 1 minus 1/3 x minus negative 2, which becomes the absolute value of 3 minus 1/3 x. This simplifies to 1/3 times the absolute value of 9 minus x, which equals 1/3 times the absolute value of x minus 9. And the absolute value of x minus a becomes the absolute value of x minus 9. So here we have a multiple of 1/3. Hence, we want 1/3 times the absolute value of x minus 9 to be less than epsilon, which is equal to the absolute value of x minus 9 being less than 3 times epsilon. Thus, delta equals 3 times epsilon. Isn't all of this amazing? Amazing questions. Okay, problem 20. The limit as x approaches 5 of 3/2 x minus 1/2 equals 7. So here are the two functions that we are getting. The absolute value of f of x minus L becomes the absolute value of 3/2 x minus 1/2 minus 7, which simplifies to the absolute value of 3/2 x minus 15/2. And this equals 3/2 times the absolute value of x minus 5. And the second function we're getting is the absolute value of x minus a is the absolute value of x minus 5. Did you see the pattern? Well, I see it. There is a multiple of 3/2. So now we want 3/2 times the absolute value of x minus 5 to be less than epsilon, which is equivalent to the absolute value of x minus 5 being less than 2/3 epsilon. Thus, delta equals 2/3 epsilon. So, isn't it easy? We first identify a and L, and then we simplify the absolute value expressions. And lastly, we find the constant multiple. Done! Now, repeat after me. Math is simple. Math is easy. I love math, and math loves me. I hope you all have a great day, and I'll see you in the next video. Subscribe if you liked what you've learned today. Namaste.